We tend to think of the internet, and especially artificial intelligence, as a kind of invisible magic. It lives in the cloud, a weightless, silent realm where answers materialize out of thin air. When you sit down at your laptop and type a quick question to an AI chatbot, the screen instantly populates with text. It feels like the entire interaction begins and ends right there on your keyboard. But this chart shows the physical reality of that request. Generating a response from an AI requires about 10 times the electricity of a standard Google search. It takes immense computing power to comb through billions of parameters and construct an original response. Multiply that by hundreds of millions of times every single day. The global demand forces a massive strain on our energy infrastructure overnight. If you follow the tech industry, you might assume the biggest roadblock to handling all this data is a shortage of specialized silicon chips. Yet the true physical bottleneck threatening to choke the AI arms race is far more elemental. We are running out of the electricity and water required to keep these machines running. To see where your digital prompt actually goes, you have to look at places like Data Center Alley in Virginia. Fully 1/3 of the entire world's internet traffic flows through this single concentrated region. Here, the virtual world takes the shape of massive, windowless concrete boxes, many towering up to 80 feet high and stretching across acres of land. And they are anything but silent. People living next to these facilities endure a relentless mechanical drone that never stops, 24 hours a day, 7 days a week. That noise is the sound of survival for the servers inside. The computers processing your prompts run incredibly hot. Without industrial-grade cooling fans constantly flushing out the heat, the hardware would literally melt down. Our appetite for instant virtual convenience has birthed a sprawling, noisy, and blistering hot physical footprint right in the middle of everyday residential neighborhoods. Noise is only one byproduct. Developers are increasingly expanding these server farms into the drought-stricken Arizona desert. To keep the hardware from frying in such a harsh climate, tech companies rely on evaporative cooling systems. These systems pull in local water and spray it across specialized pads to absorb the heat before venting it outside. The scale of this thirst is staggering. Regional data centers evaporate up to 1 million gallons of water every single day to keep their systems stable. And that's just maintenance. Training a single large language model from scratch requires the water equivalent of a small nation. The upkeep of artificial intelligence is now in direct competition with human communities for the most precious natural resource in some of the driest parts of the country. Beyond local water scarcity, there is a systemic crisis hitting the national power grid. This chart outlines projections from the International Energy Agency. Notice the flat line representing our current grid capacity, contrasted with the steep curve of AI data center electricity consumption, which is set to more than double by 2030. To understand the severity of this deficit, listen to industry veterans like former Google CEO Eric Schmidt. He points out that the US alone will require an additional 92 gigawatts of new power generation just to keep pace with AI demand. That translates to the total energy output of 92 entire nuclear power plants. We are trying to build the hyper-advanced intelligence of the future on top of a mid-20th century electrical infrastructure that simply does not have the math on its side. Faced with this immediate grid deficit, tech giants and regional utility providers are moving into full-blown crisis management. The sheer, unyielding power demand of the AI boom has already forced several states to quietly abandon the long-standing environmental and carbon reduction targets they spent years negotiating. Power companies are extending the lifespans of highly polluting coal and gas facilities, delaying their retirements to keep the server farms running. The most sophisticated digital technology humanity has ever created is currently reliant on resurrecting the dirtiest energy sources of the Industrial Revolution. Generative AI offers tremendous, world-spanning capabilities, but the defining challenge of the coming decade won't be writing smarter code. It will be figuring out how to power a virtual utopia without burning down the physical world to do it.